we are diving even deeper into the AI applications in health. Okay. On behalf of my faculty team here, Charlie Goldberg, Ethan Suresh, Stephanie Allen, part of the HITS team, want to welcome you back, and I hope you had a good lunch and good conversations around lunch. Now, this afternoon, we're really fortunate to have Dr. Eric Topol. I'm sure he needs no introduction. You've been following his Substack articles. I mean, he's extensively well published in terms of papers and books, and now very, very active on social media as well. So we're really fortunate to have Eric kick off the afternoon, and then will be followed up with other talks. Thank you.
Thank you. Okay, we got the slides back up. Great, thank you. All right, so let me go ahead and get right into the topic at hand. Does anybody know who said this? The symbiosis of human and machine intelligence is forging a new epic of cultural. It doesn't work?
Now, closer.
Does it work now?
Yeah.
Okay. Okay. Does anybody know who said this? T4. Okay, so we're going to first talk about medical errors because there's a lot of them. We don't like to fess up to them in the medical community. According to Johns Hopkins, the most recent paper on this subject, there's 800,000 Americans die or are significantly disabled, that is permanently disabled, by a medical diagnostic error each year. That sounds pretty bad to me. I don't know about you. So we keep talking about precision medicine. But if you keep making the same mistake over and over again, that's very precise. So what we need is accuracy in medicine, which we're lacking. And hopefully we can improve upon that. In fact, it might be hard to make it worse. So first, let's talk about what unimodal AI has done, which has been around for several years in health and medicine, and is, of course, relying on supervised AI, where you have ground truths with experts who have to review the images. This is mostly an image-centric era to review, and it's hard to get these big data sets because you can't get clinicians to spend their time doing annotations of images. At any rate, a lot of progress was made. Like here as an example of a chest x-ray, which radiologists missed the nodule in the upper right lobe that was cancerous. And that's not that uncommon in large data sets, retrospective chest x-rays. So the largest study in the history of AI in healthcare has actually been done and is ongoing in Sweden with 80,000 women. Half of them had AI support of either single or double reading, and the other half had just the usual reading in Sweden, which involves 2 readers. And the AI provided significant improvement in picking up breast cancer, and also a 40% plus reduction in time, the workload of the review of the mammogram. Now, what's interesting, the first place that deployed this at scale in the world was Hungary, of all places. And this was written up in the New York Times, and in fact, journalists in the New York Times actually went to Hungary to see with their own eyes what was happening. And there are many studies now that show that AI algorithms for breast cancer mammography increases the detection of breast cancer by about 12 to 15%. It's very consistent from one study to the next. In fact, the workload was markedly reduced, and just like we've seen in other studies, in the real world, there was an improvement in Hungary of about 13%. And that was in 16,000 women using this Kiron, which is now one of over 20 breast cancer mammography algorithms that are FDA cleared or approved. Now, what's really sad is that one of these is called RadNet, and they have these RadNet facilities. I don't know if we have one here in San Diego, but they're all over the country. Do you know, Chris? No. At any rate, they are now charging the women to get this mammogram AI interpretation $40 out of pocket because it has no CPT code. And of course, this doesn't seem to be the right way to move forward. This is not how it's going in Hungary and other countries. It's just part of taking care of patients, which is one of the reasons why we are not well positioned in this country to integrate AI, because we have a fee-for-service model, and we rely on codes and CMS and all sorts of things, whereas other countries that have universal health care and want to take care of their patients the best way, they don't have this problem. Now, akin to mammography, colonoscopy real-time for gastroenterologists is the other big, well-studied, supervised AI, unimodal AI. And now there are 34, this is updating, 34 randomized trials of colonoscopy, and it shows overall a 50% reduction of missed polyps. And it only took, on average, 20 seconds more to have the machine vision real time during the colonoscopy. And interestingly, some studies have shown that the missing of polyps gets worse and worse as the day goes on for gastroenterologists, which is no surprise, of course, but it's been verified. Now, before I go on to the next part of this, the problem with these mammography and colonoscopy studies is that AI makes the accuracy of picking up cancer much higher, but it hasn't yet been shown to change the outcome of patients. And that relies on ongoing trials, particularly that 80,000 women trial in Sweden. Now, those studies I mentioned were just about determining what clinicians can do, what radiologists can do, gastroenterologists. What about what humans can't do? And this is a product, again, of unimodal AI. So take, for example, the retina. It's amazing how rich information that we can't see, but AI can pick up the control of diabetes and blood pressure, whether the person's going to develop kidney disease in the future, liver or gallbladder disease, the heart calcium score, which is the same aligned with the actual CT scan of a patient's heart. Picking up Alzheimer's disease 5 to 7 years before any symptoms are manifest, predicting heart attack and stroke, risk, hyperlipidemia, and Parkinson's disease, again, more than 5 years before there's any symptoms manifest of Parkinson's disease. That's pretty remarkable. And you can think that in the years ahead, we'll take pictures of our retina through our smartphone and do a checkup. And this is all, of course, unimodal AI, and it applies equally to other images, perhaps not quite as dramatic, but here's the ECG 12 lead. It gives the age and sex. I've been reading cardiograms. I love to read cardiograms for decades. I could never tell you if it's coming from a man or a woman, or a precise ejection fraction of the heart, many difficult diagnoses, the anemia to the decimal point of hemoglobin, atrial fibrillation in people who've never had atrial fibrillation and their risk of stroke, diabetes or pre-diabetes from the electrocardiogram, the filling pressure of the heart, whether there's hyperthyroidism, kidney disease, and peripartum cardiomyopathy. All these things that we can't do as cardiologists experience ECG readers. And the chest X-ray, interestingly, has been shown to also provide whether a person has diabetes or pre-diabetes. The saliency map goes to the fat pads, the mediastinum, which is really interesting. And then various things about the heart that we could not possibly discern accurately, and even race of the patient from the chest X-ray, which would not have been anticipated, and it brings up all sorts of bioethical issues as well. Now, what about pathology? Because as you know, pathologists read slides. Do we have any pathologists here? No. They read slides and they are read subjectively. And there's disagreement about what the slide shows. And this is important, especially, for example, in patients with cancer like this slide. Well, now with the same deep learning, we have driver mutation, whether it's malignant or benign, the site of origin, which is elusive in about 5% of patients that can be determined pretty accurately through AI, structural genomic changes, response to therapy, and the prognosis of the patient, all through the slide, the whole slide image. And this is extraordinary, right? Also extraordinary, not related to this, but this is revving up drug discovery, and the best example I can offer at this point is from Jim Collins and his group at MIT. They published a few weeks back the first structural new class of antibodies in 38 years. And they discovered drugs that have very marked efficacy for methicillin-resistant Staph aureus. So this is a big thing since we've not had much progress in antibiotics, and this was a major step forward. So it isn't just images. This was actually, we'll get into in a moment, a transform model that really worked well. Somebody was asking before we got started about the patient side of all this. And most times when these conferences occur with AI in healthcare, we don't talk about the patient benefit directly. And that's the ability of having direct access to AI. And so, for example, we can make doctorless screening diagnoses now, not just for atrial fibrillation through a smartwatch, but also through various skin lesions and rashes, urinary tract infections. That's available in many other countries. Soon will be here an AI kit that you can get at the drugstore, accurately diagnose whether there's a UTI or not, ear infections in children, and also diabetic retinopathy, which can be diagnosed in many drugstores around the country now, which is quite important since half of diabetics never ever get screened for whether they have diabetic retinopathy. There's also all these coaching chatbots for blood pressure, for obesity, for depression, diabetes, and the list goes on for most chronic conditions. So now let's switch gears to the current era that basically became awareness with the release of ChatGPT at the end of November last year, I should say 2022. And this was a area that was percolating since 2017. This is unsupervised or self-supervised AI. So it's perfect in medicine because it doesn't require creating data sets of annotated images with clinicians. And so rather than the usual deep neural network, which is basically a unimodal construct, this is multi-head attention that is really setting up the ability to do multimodal AI. And that is transforming the landscape of medicine and healthcare. Now, just to review, the GPT-4 is still, despite the challenge today with the Gemini Ultra challenge, GPT-4 still stands as the prototypic large language model, most powerful as of right now. it has over 1 trillion connections, which is compared to the brain, which we average about 100 trillion. But packed in that 1 trillion connections is an extraordinary amount of information. And what's really interesting is that this required over 24,000 graphic processing units, which is a lot of computing power. How many GPUs do you have at UCSD? Anybody know? If you had 200, I'd be surprised. So this is an oligopoly now of Google, Microsoft, OpenAI, Meta, and a few others in the world that have this much GPU power to basically train base models. Now, we worked with Pierce Keane and the group at the NHS, the leading eye center in the world at Moorfield, on this study that was published last fall. And all those things I showed you about the retina in separate studies, done unimodally, with supervised learning, we did with 1.6 million retina images with a foundation model, and that's what this Nature paper showed. Now let's go to where multimodal AI is taking us. As you know, there's all these different layers of an individual, which we now can collect that data, all these layers. And some of it is limited, like for example, some is quite cell and tissue specific, but for the most part, we can collect an extraordinary amount of data for any given person. And it's what makes us unique. And it's not a one-off, whereas a whole genome sequence would be done once. Many of these things would be done serially during a person's lifespan. And when I wrote this paper back a decade ago, Bill Kelly subsequently told me, who was a mentor of mine from my days at Michigan, the title there, you should have called it From Lust to Dust. He was right. Would have been a more catchy title. Okay, so there's a very good review article from the group at Stanford just a couple of weeks ago in January on large language models in medicine. This is a graphic about where we stand for medically tweaked, fine-tuned base models. And we still are in the early stages of those. Most of the things that have been done to date are ChatGPT or GPT-4 or basically large language models without specialized fine-tuning. I wrote a piece in Science about how these applications with multimodal AI are going to multiply, and it is really a big shift ahead. One of the ways we can do this, just like weather forecasting, which takes in many, many layers of data and is much more accurate than we've ever had for weather forecasting. The same is for life outcome. And for example, our ability to reboot how cancer is screened. I think you know now that pancreatic cancer is lethal, short-term lethality in 90% plus people. It's diagnosed very late, and we don't even know who's at risk. Now we're defining through multimodal AI who is at risk and the ability to pick it up much earlier. And interestingly, it's not just from abdominal or chest CT picking up something abnormal about the pancreas, but it's also about, this is from Denmark and the VA system, from the electronic health record, things that would not have been seen, detected as far as trends, and it also the unstructured text to make a difference in defining who is at risk for pancreatic cancer and who would be under surveillance so they don't get diagnosed late, and ideally don't get diagnosed at all. So this is one area where multimodal AI, so all these different layers of data, is going to reboot how we screen for cancer, because today it's really incredibly dumbed down. If you're 50, you go for your whatever, 40 for mammography, I mean, it couldn't be more dumb. It's by age alone. And we have people in their 20s that are developing colon cancer now. In fact, that's the biggest increase right now of colon cancer. We have women in their 30s that are developing breast cancer. We don't know why. You can guess what possibly could be some determinants of that. But we need a better way for doing cancer screening, and I think we're onto it. We're obviously in the early stages, and this paper last July went through the fact that there's about 12 different randomized trials assessing rebooting of how we do cancer screening for various cancers. One of which is we still don't even refer to cancers by their molecular characteristics, but instead their organ, which is about as old as you can imagine, because it doesn't matter so much the organ as it does molecular features as to how it is best treated. And so multimodal AI is going to take us to hospital at home, to better pandemic surveillance that is individualized and real-time, digital twins, and many other things that we reviewed in this Nature Medicine review paper. So now let's get to the next very exciting aspect of where medical AI, I think, is taking us, and that's asking questions. And this recent Washington Post editorial, why AI could be the new medical mystery detective. Well, it's happening. This is a famous case now of a young boy who at age 3, his name is Andrew. It was noticed that he had not just horrible pain, but difficulties in walking, dragging his left foot, headaches, and growth arrest. His mother took him to 17 doctors over 3 years, and there was no diagnosis. So finally, she put all his data and lab tests in ChatGPT, and within seconds, it came out with a diagnosis of occult spina bifida. She then took him to a neurosurgeon in Michigan, where they live, and that diagnosis was indeed confirmed. And he underwent surgery, and he's on the way to being normal in terms of growth and everything else. So that's just one example. It's an anecdote, but there's lots of anecdotes. This is a family who, patient of mine who the sister put all of her sister's lab data and symptoms after she had been told she had long COVID. Saw several neurologists and physicians over 6 months, and it turned out by ChatGPT she didn't have long COVID. She had limbic encephalitis, which is eminently treatable, and she did get treated, and she's fully recovered. There is no treatment, I think you know, that's been validated for long COVID. So one of the ways we can try to get at how good is AI right now is to use these CPCs, the famous case records of the Massachusetts General Hospital, man's greatest hospital. So this is 100 years of this now. 100 years, started 101 years, 1923. And those master clinicians presented the difficult, complex case. So that's a pretty high bar to have the master clinician of the CPC versus the AI. Well, time and time again, there are 70 cases matched by GPT-4, JAMA last year. Here's a study that was reported by a Google set of researchers, marked improvement of accuracy for 300 CPC cases using the large language model versus 20 board certified internists with 9 years average experience. Then this whopper of a study that was published last month, this is another Google group of researchers. They took 20 primary care physicians and they presented 149 case scenarios. And these are complex cases. And for 24 out of 26, the diagnostic accuracy was better with the AI. The AI is called AIME, AIME, and it's basically an outgrowth of their prior large language model. But it wasn't just the accuracy that was improved. It was everything. And it's pretty remarkable. The patient management, the patient communication, the empathy, the whole long list. And so this is really a fascinating result. All of these studies are not the real world, but they're giving us some insight about how good AI is right now and how it's only going to get better for accuracy of diagnosis and other medical tasks and responsibilities. So in the last week, I wrote about towards the eradication of medical diagnostic errors. When I wrote this, that new paper I just cited, preprint, wasn't even published. And so it just shows you how this field is moving so fast. The Nature headline for that paper was Google AI has better bedside manner than human doctors and makes better diagnosis. Yeah, that's what it did. Okay. Now, how are we going to restore the patient-doctor relationship? Because it's pitiful right now. Having been a patient, I don't know what your experience is when you go see a doctor, but you have very limited time. Typically, the doctor's not looking at you. They're having to type things like in a keyboard amidst all their other data clerk functions. And so this has to stop. This was the ruination that was induced by EHR decades ago, and it's never been alleviated. And it's transformed clinicians, and that includes nurses, pharmacists, and so many other healthcare professionals into data clerks. And it's not just during work hours, it's also during so-called pajama time, right? So this was just published this week. This is the Permanente Medicine Group up in Northern California. They have over 3,500 physicians using one of these ambient conversation large language model synthetic notes. And 81% of them thought this was great, of the doctors, and 71% of the patients said they were now communicating much better with their doctors. And they only had a random audit of a very small subset of notes, but it was exceptionally high quality. This was on the front page of the New York Times at the end of June, and it was these physicians talking about how they're saving hours of time. And these systems of ambient conversation during a clinic visit are now used in certain health systems in the country by every physician. And they're making a big difference. And hopefully this is going to be something that's the standard practice in the short time ahead. So just in wrapping up, I used to think this was true. This was published in Health Affairs in 2020. There's no algorithm for empathy. Well, the paper that was published by the UCSD group here suggested the Reddit doctors that volunteer to post on Reddit were basically transcended by the ChatGPT performance for empathy, no less quality of response to 200 medical questions. And I said, well, that's interesting, but that's just one study and it's Reddit doctors. And well, anyway, all the studies are showing this, all of them. And so that first study that was published by Ayers and the group here is now getting replicated in many different ways. And so who would have thought that an AI that doesn't even know what empathy is actually promoting empathy? Okay, that's what's really fascinating. And this will help the patient-doctor relationship, which has suffered so much over recent decades. So instead of the fast time that we have, the limited time we have with patients, this is the system 1 and 2 thinking story. So system 1, of course, as you know, is reflexive. And that's what we have, 7 minutes with a patient to think of what's going on, to think about the diagnosis. It's such a shallow experience, both for physicians and patients. And so this has to change, and that's what I had thought was going to be the thing that helped the patient-doctor relationship, but it's obviously much bigger than that. And all these different features are going to hopefully bring us back to where it was many decades ago, when it was extraordinary. That was an intimate, highly communicative, trust bond between two human beings. Now, before I wrap up, I have to acknowledge that there's all these long list of bad things with AI. I mean, bad things, right? It's not a pure play here. It's not simple. Nothing's simple. And the dark side of AI is here earlier last month, or this cartoon, this advanced AI will expose AI with deceitful or malicious intentions. And how do we know it's not lying? Yes. These is just a short list of all the problems, the bugs that have to be worked out. And it's only a partial list. Part of it is us, or our resistance to change, but is it going to get reimbursed, medical, legal issues, regulatory? There hasn't been one multimodal AI cleared or approved by the FDA, only unimodal. So this is a new threshold to be keeping an eye on. Transparency doesn't hardly exist about these AI models. Where is the compelling evidence? And where is the trust from the algorithms to the algorithms by the medical community? How is it getting implemented, and what is the surveillance after implementation? Because bad things can happen to software, as everybody here knows. So I'll just leave you with one of my favorite essays. It's probably ever been written in medicine by Francis Peabody almost a century ago. It's about 5 pages. It's an inspirational read if you haven't read it in recent times. But the last line is, one of the essential qualities of the clinician is an interest in humanity. The secret of the care of the patient is in caring for the patient. And that's what I hope someday AI will take us to. So this is our group at Scripps Research, our Translation Institute, our funding sources. Thanks so much for having me today. I look forward to your questions. Thank you.
Thank you, Dr. Chopin. This is really terrific. So we have time for, already there are some questions coming up here. So we can hand over the mic back to you.
Dr. Tomal, thank you for that inspiring talk. Now, one of the problems that we have in medicine is that we're stuck in a paradigm in which we wait for a patient to have symptoms in order to begin an assessment.
Right.
Okay, what we should be doing is proactively looking at people as young as possible and figuring out what the predictive analogs is for the illnesses that they are going to confront. And you went a long way towards assessing that. Now, there are companies out, sharing that information with us. There are a lot of companies out there now, like Longevity Inc., et cetera, that are doing PET scans and genomic assessment at a cost of $20,000 per person,
Right.
to try and move the paradigm. But that is not really applicable at scale for our population. It's kind of an outrageous cost that is only applicable to the wealthy members of our society. So how do we move from the paradigm of waiting for symptoms to exploiting this to identify things long before? You mentioned about the ophthalmologic approach with the retina. How available is that? How soon will it be available? And how soon will it be possible for individuals to do it without even going to a doctor?
Great. I'm so glad you asked about that. So you're absolutely right that even Longevity Inc. was an example of that here in San Diego. And when I spoke to the New York Times about that it was a recipe for incidentalomas, that's when Craig Venner cut me off. And then he won't ever talk to me again because he was the person who founded that company.
Right.
But it's true. And basically that instead of the criteria being age, it's being rich. Okay. It's ridiculous. $25,000 to have not just a total body MRI, but all these other tests, right? And he has testimonials, including himself, Craig, that saved their lives. Well, those are anecdotes. We don't know how much harm it induced as well. Now there's a very popular company that's springing up all over the country called Pronovo. Pronovo is an MRI total body that you can get for $3,500. And a lot of people are getting this, in fact, because they think it'll spot cancer. Well, it's also, if you read the New Yorker, Drew Cooler, who's one of the physician journalists there, he went and did it to write, so he could write a story. And he's a young guy. I think he's maybe barely 40. And he had a prostate abnormality. Now he's going to be going through all sorts of extra tests and probably will be nothing there. But the problem with these extends to the cancer liquid biopsy tests. Okay, so there's GRAIL, gallery test, and it costs about $1,000. And it does the methylation across 100,000 points in the genome, and it tells you you have a cancer signal or not. Now, out of the criteria is age 50, which is the same dumbed down criteria as screening today. And guess how many people out of 1,000 age 50 will have a positive test, a signal, cancer signal, out of 1,000?
90.
5. And out of those 5, how many are stage 1 or 2? 2. So 2 per 1,000, right? Is that the best way to screen for what? But what if you've done all the work to partition high risk? And maybe some of these tests are good, like the GRAIL test or the MRI, but only in certain people who you, by multiple layers of data, you define and they are high risk. And that's, I think, where we're headed. But we haven't gotten there yet. And the other thing that you touched on is the virtual health coach. So someday, perhaps several years from now, perhaps longer, the way things move in medicine, we'll fulfill the fantasy of prevention, primary prevention, which is what you're getting at, where all your data, if you so choose, will be continuously fed back to you with coaching about how you won't get that condition that you have high risk for. And that might include getting a scan or a blood test or changing your diet or all sorts of things, right? That's someday what AI multimodal can do, although nothing exists like that right now.
23andMe is on the verge of bankruptcy right now, which it was the darling of social media a few years ago.
Yeah.
Could you just comment a little bit on what role will AI play constructively in genetic analysis?
Yeah, I mean, I think unfortunately we've made a lot of false steps. The genomics data is rich, but it's how it's used, right? So 23andMe had a SNP array for over 600,000 common variants, but to get polygenic risk scores out of that, which would be useful to find if you fit in the top 1% of whether it's different cancers or type 2 diabetes or heart disease, that's really useful information at the individual level to weigh in with everything else. But they charge a subscription to that, and that wasn't going anywhere. To get it, you should get all that data as part of your test, So we haven't seen the right genomics company that is giving high quality information. Now the whole genome sequence can be done by places that are doing scale at less than $200. That is at cost, less than $200. So I think we'll see that eventually. But 23andMe hasn't provided, nor has Ancestry DNA or all these other genomic DNA companies. There's a bunch of them right now that are starting to try to provide polygenic risk scores. I spoke to a couple of them this week, but they're in the earliest stages, and they're not cheap. Like $350, that's not going to go over well. You could have a whole genome sequence instead of a polygenic risk score. So lots of missteps along the way, but eventually we'll get there.
Thank you.
Sure.
I'm just curious how the regulatory issues such as HIPAA that historically kind of had reasoning, are they now helpful or interfering with curating cohorts that really help us to validate the data?
Yeah, so the regulatory is a big mess. And the reason I say that is there's been about 650 AI algorithms, all unimodal, that have either gotten cleared by 510K or actually approved by the FDA. The number of those that are actually prospective studies, no less randomized trials, is very limited. The number of those that actually publish their work ever is even more limited. So there's very little transparency, there's very little opportunity for the medical community to review any of that data. The companies say it's proprietary. They're often based on small retrospective, which is not the real world in medicine data set. So regulatory, here's the problem. That's all in the unimodal. And now that could actually get worse if they start doing the same promiscuous lack of oversight, lack of teeth, and basically putting out all these, and then we'll have another story like the genomics front, which is a good idea, but not executed well. And we don't have, there are some good examples. I mean, like one of the early examples was that diabetic retinopathy. They did it was a University of Iowa spin out called IDX. They've since renamed the company. But they went ahead and did a prospective trial. And they are, as I mentioned, in grocery stores throughout many parts of the United States. They did it right. But that model hasn't been followed by too many others at this point. And that's really unfortunate. So regulatory is a big, sticky issue. And I don't see any light coming at FDA to make it better. We're certainly not going to take away these clearances and approvals. And so many of them are really very shaky.
Question down the back.
So, curious, the new ChatGPT seems like it's going to be the new WebMD, and a lot of the data sets that people are viewing these chatbots are run by different companies. Will there be, probably not, but will there be a violation because transferring of data sets of health information, which will be on the servers of these different companies who will try to use that data in a way that might violate HIPAA procedures? Do you see that as a possibility? Unless a university like University of San Diego, University of California, San Diego, build their own LLMs and then collect the data here. But most people will be using other people's LLMs to provide their medical information, and they will use that information in ways that might violate. Do you see that as a possibility?
Well, there's a lot to unpack with that one. I don't even see the similarity between the GPTs to like a WebMD or even a Google search, because you're putting in specific data. Oftentimes, it's not just symptoms and lab tests and all sorts of things, and you're having an interactive conversation. But the point you're getting at is about privacy. And this country doesn't show up in privacy. 2/3 of Americans have had their health data breached at least once. What are we doing here? And so, yes, the possibility you're bringing up of you put in the data and then it's now brokered to the company that's interested in your whatever area, right? That's a fiasco waiting to happen, potentially. And we're not doing anything about it here. So I'm concerned about that. That's what happens now with current surgeons. The other thing is you can't have a regulatory oversight of patients doing GPT searches. That's not going to happen. I'm not going to say you're not allowed to do a search, so we're not going to be able to regulate that either. So the only thing we can do is try to get to privacy. Now, the good news there is a lot of AI privacy computing problems. Like, for example, AI at the edge in the smartphone, so the data never leaves the smartphone. That would be a welcome shift to try to protect this data. And that's something that here in town, Qualcomm has been a leader. But whether or not we're going to get serious, this country is just like a sieve for data, whether it's data brokers and selling our data, health data that is, or these health system breaches. And this is just, we have a very bad track record here, unfortunately. It's shameful. We're not doing anything about it. It's just basically accepted as the norm. We're numb to it. Really concerned.
Should somebody have all their multimodal data?
Yeah.
Are there companies that are working on getting it all together? Who's in the forefront there?
Yeah, there are companies. There's one called Picnic, which is kind of a funny name for this, right? Because it's no fish. And there's others that I've heard of, but there's just not enough activity in that because in other countries, it was started with Estonia and now it's Finland and Switzerland and everything else. They're doing it as every every citizen has all their health data in one place that they own, they control. That's what it should be here.
Yeah.
So you shouldn't have to pay a company to do it. And it is unwieldy to gather all this stuff and have it organized so you can share what you want to share with any particular thing. Yeah.
But who's putting it all together in terms of the story of, oh, my son has spina bifida, or who's doing that?
Well, that's what these companies supposedly are aiming to do, is to get it all organized. But it hasn't progressed very much. That's where it should be. Everyone, or parents for their children, should be the owners and controllers of the data. And whether that's for a research project or a specific appointment or, whatever it is, that's who should. It shouldn't be in health systems that get hijacked routinely. Yeah.
I was wondering, for those of us who may not have read the article on empathy there, I'm 35 years old and still in the camp that, physicians haven't really mastered the whole art of empathy. Just a couple of weeks ago, I was at a doctor, and she clearly a very, very qualified person, has a great resume and such, but it was just like I was talking to a robot. Can we go a little bit deeper? So looking at it from let's say 20 years from now, the outcome of that, how will that change the, what shall I call it? Basically the personality of who ends up being in a medical institution as opposed to who does not. From my experience, the majority of people who made it into medical school right after undergrad were mainly those A+ students who were able to memorize materials and go back to it, as opposed to individuals who could just necessarily have a conversation with someone sitting next to you. So barring that, I'm still not sure where that empathy clause, really applies.
Okay, two things I would offer. First of all, my prediction is in the next few years, certainly within 5, it'll be a requirement for every physician to have been coached by AI to be more empathetic and better communicate. It'll be a licensure requirement. Okay, once the notes get automated, we've already seen incredible evidence of this. It says to the Dr. Jones, why did you interrupt Mrs. Smith after 8 seconds? When she had deep concerns that you didn't listen to, and you never gave her a chance to go over this and that. Okay, this is now what you get out of these notes. I didn't even touch on the fact that once you have an automated note that's high quality, it does pre-authorization, it does the next appointment, procedures that need to be ordered, prescriptions, and nudges the patient for whatever you discussed during the visit, and coaches the doctor. If the doctor is willing to be coached, which is a whole other story. But it'll be a requirement someday, all right? The other big thing is that we will pick doctors to go into medical school for different criteria. They don't need to memorize everything, but they don't need to have the highest MCAT scores or grade point average, but they sure need to be people, right? And that's not a selection, it's almost an anti-selection criteria. So we need to do much better of that. And it's going to take a long time, because changing 150 medical schools in this country to do anything takes, years and years. But eventually, I think there'll be a new way to select the next generation of doctors. And between that and the coaching, I'm optimistic.
Dr. Topol, on that note, are there any evidence to date of the studies that you presented here, or that ongoing, that AI could be less susceptible to bias in diagnostics?
Actually, we keep blaming the AI, and it's us. Look in the mirror. We're the bias force, right? And all the content that's in these models is just from us. So the only other thing that we can do, we can't fix this bias because it's profound, is that we have to be smart in building AI models to be interrogating that and doing everything we can to try to neutralize or diminish its effect. But it isn't the AI per se, it's the fact that there's these models that are basically where this is embedded. And bias is a very big issue. And in the science paper just last week, I wrote about that's the thing that's really holding us back. And we will have mistakes being made about diagnoses and treatment, all sorts of things because of the bias. And because a lot of our inputs are oftentimes not diverse populations. For example, that has been a problem in the genomics field and getting alleviated in recent times, but it's still a very big problem in this field.
I'll project. I love football, and we've got the Super Bowl coming up.
Oh, Chiefs. I've heard of that.
You've heard of it. And so, I'm one of those guys that run out and get the latest TV, right? I'm one of those early adopters, pay way too much for the next high definition, this and that. And it struck me that those people are celebrated because eventually the costs come down on those TVs and the masses get to adopt new technology. But in a lot of the healthcare technologies we're talking about today, we do have those people who do pay tens of thousands of dollars for these new solutions coming out. But we don't see it trickle down to becoming affordable for the masses. I'm wondering what your insight might be on why that is. Why did the technology get stopped?
Because we're stupid. And that's the reason I say that is, take the smartphone, right? The people who read that would benefit the most to avoid an emergency room visit or hospitalization, we should be giving them a smartphone, okay? With data plans. We could give them a smartphone and a data plan, and that would be, for 2 years use, that would be cheaper than one night in the hospital. But we don't do that because we don't think like that, and because of our cockamamie fee-for-service insurance system. Which insurer is gonna do that, right? And so, we haven't seen Medi-Cal, Medicaid programs that could try to, come to life to do something progressive. I just give you as an example. We should be giving things to people to help, because the cost of a hospitalization or emergency room visit and all the other things that happen during that kind of encounter are extraordinarily high. And we can provide inexpensive smartphones with bandwidth to people with the suitable apps. It has never been done, to my knowledge, in this country, which is amazing. And that's just one example of a digital divide that's unnecessary, that we should be working on, but nothing gets done.
We're doing it here.
Oh, you are? You're giving out smartphones?
One last question.
Wow, that's great. I didn't know that.
Thank you. Following up on that, do you think that devices like Apple Watches and Fitbits, as they're used to collect more like body temperature information and heart rate variability, do you see those playing a role in how medical decisions are made, how insurance claims are approached? Thank you.
Probably not, just because we are not set up in our health system to take in any patient data. So, good luck to get that into the EHR in the times ahead. I do think that these overall sensors can provide very useful information. It could be glucose sensors. It could be all sorts of sensors like the ones you mentioned that are widely used. But basically anything the patient does is in a separate compartment, another orbit, which is ridiculous since that data is rich. So just like the genome is not going to, whole genome sequences are not going to get into charts either. That's why, going back to the question earlier, it's incumbent to have each person have all their data and organize and crystallize the process so that it can help coach that person. Because I don't envision what you're asking to become a reality in the near term, if ever.
Okay, thank you, Dr.
Thank you.
Okay. We're going to continue on. If you want to get a quick coffee here, but we have a great next set of speakers led by our new Chief AI Health Officer, Karandeep Singh, who has actually worked on a lot of these topics and involved in a number of initiatives like CHAI and whatnot. So he's going to talk about some of that. Okay, so please get in 5 minutes, 5-minute break. Yeah.